Thank you, everyone. Why we measure stacked particulate matter continuously? There are several reasons. More importantly, it's a regulatory. Environmental regulations are laws and policies designed to protect the environment and human health by controlling pollutants and managing natural resources. They encompass a wide range of standards implemented at various levels, including federal, state, and local. Environmental sustainability goals, reducing pollution emission into the atmosphere will ensure healthier environment for people and planet. At Auburn, we are passionate about clean air, and all our products and solutions contribute to green environment and to the Clean Air Act. And equally important is cost saving. A statistic from US EPA in 2021, they imposed $1 billion in assess penalties and fines. Also, unscheduled downtime to production can lead to significant financial losses. The regulatory landscape is all over the map. In US, the EPA PS11 is dominant, as Bob mentioned. Canadian-wide standards, Industrial Emission Directive in EU that you are more familiar than I am, Asia-Pacific Clean Air Partnership, and in Australia, National Environmental Protection measures. So there are different regulations for different regions of the world. The measuring principles, there are various principles. The four dominant ones are light scatter, triboelectric or charge induction, which is Auburn's technology, opacity, and gravimetric or spot checking. They all monitor the particulate flowing through a stack and the amount of it, and all had a spotlight as a main solution at some point in time. Light scatter technique, light source transmit a beam into a duct or a stack. The intensity of forward deflected light or backward deflected light is measured by a receiver. Typical industries include power, cement kilns, and incineration. You're going to notice common industries across all different technologies that I mentioned in previous slide. Next, triboelectric or charge induction. A probe rod is inserted into the process, and as the particulate go by the probe, they induce a charge. And the electronics captures that charge as a specific bandwidth and measures and reports the output that is human readable. Capturing the specific frequencies of actual energy from dust is very important, because by knowing that frequency, with the electronics filtration, we can filter out noise from vibration or change in velocity, and only measure or report actual charge from particulate. So the signal to noise ratio of our charge induction instrument is higher than some of the other technologies. Typical industries include power, cement, metal, incineration, and powder and bulk. Opacity or light attenuation, it measures the decrease in the intensity of light beam as it passes through the stack gas. This was dominant at the early on in the coal-fired power plant, but it loses its favoritism because of the sensitivity of detecting low-level detection of particulate levels. It was the typical industry. They were dominant in coal-fired power plant, cement kilns, incineration, and asphalt. Gravimetric or spot checking, it uses differential weighting to determine the mass of particulate matter collected on a pre-weighted filter. This method requires a control lab environment to perform analysis on the sample pulled from the stack with a pump at the same velocity as the stack flow. So it's extractive measurement. It doesn't provide continuous monitoring. The typical industries are power, cement, metals, pulp and paper, food and beverage. Classes and subcategories of particulate monitors. In the class of mass output, there are two categories, PM-SEMS. This is the highest accuracy with the continuous mass output. The dominant technology is light scatter, followed by beta attenuation. The beta is losing its appeal because it's very costly and very high maintenance, and with the light scatters becoming more sensitive, they are replacing that beta attenuation. For general quantitative, it's less stringent as on the accuracy side, but it does provide a continuous mass output. The technology used are